Welcome. Here we're going to talk about another example of integration by substitution. So let's consider the integral of x squared plus x cubed plus 1, times the square root of x cubed plus 1 dx. Now, I'm not allowed to distribute the x squared in order to simplify this, and you can see the description for a link to a video where I talk about the algebra of that and we look at why that doesn't work. But I can't really make this into a simple polynomial, so I'm going to attempt alternate methods of integration. I'm going to do substitution because I have an x cubed and the derivative of x cubed is 3x squared. So whenever you have something and its derivative present in the same integral, then that is usually your big clue that you need to do integration by substitution. Now, I do have a little bit of a problem because the derivative of x cubed is 3x squared, and I only have an x squared. But that's okay. A constant we can deal with. I can't deal with it if it's another variable or there's a different power. That won't work. But if it's just a constant, we can handle that. So let's go ahead and jump in. The first thing I'm going to do is identify u and what I call the leftovers. So if u is x cubed plus 1, I'm going to take that plus 1 because it doesn't change my derivative. So if you can't, choose as large of a thing as you can without changing the derivative. The derivative of x cubed and the derivative of x cubed plus 1 are the same number, are the same thing. So that is what I'm taking for my u. And then the rest, kind of the leftovers, is going to be x squared dx is left over. So I will be placing this internal component under the square root. That will be replaced with u. I need to somehow find a way to replace the leftovers with this will be replaced with du. But I need to do a little work first. So the second thing I'm going to do is take the derivative. So du, the derivative of u, I apologize. Du dx is 3x squared, which means that du equals 3x squared dx. Now, I'm treating dx like a variable and I'm multiplying it over to the right-hand side. That is allowed and that works for problems like this. In higher level calculus courses, there will be times where you cannot treat dx like a variable, but for this instance, it does work. So I'm really close. I want to get rid of every single x in my original integrand and have only u's in my new integral. But I have one problem, and that problem is this 3. So I need to exactly replace what's in the integrand. And I have an x squared dx is what I've got left over, but in my du, I've got a 3 times x squared. So what I end up doing is, and you may not have to do this step, solve so only the leftovers are on the right-hand side. And so I'm going to divide the 3 over, and I end up with 1/3 du equals x squared dx. So when I do my substitution, it's going to be 1/3 du is going to go in for all of that. So the next step will be to do the substitution. So I will be having the integral x cubed plus 1. Okay, so that means that u is going to go in place of that. And then 1/3 du is going to go in place of the x squared dx. So my new integral will be the square root of u times 1/3 du. Now remember that constants can come out front of the integral and just kind of come along for the ride as we take our derivatives, or sorry, as we take our integral. So that'll be 1/3 times the square root of u du. Then we need to actually take the antiderivative. So do the integral, take the integral. So I have 1/3 integral. I'm going to change this to u to the 1/2 because that makes it a little bit more straightforward for me to do my antiderivative using the power rule. So I end up with 1/3 u to the 3/2 divided by 3/2. Oh, and then I drop my du, but I need to have a plus c. I'll do a little bit of cleanup here because I'm dividing by a fraction. So I end up with 2/3 times 1/3. So I end up with 2/9 u to the 3/2 plus c. Now, the last thing I need to do is to replace u. I was given a problem that had x as the variable. I need to give an answer that also has x as the variable. So I will go back to my u substitution, back to this x squared plus, or sorry, x cubed plus 1, and I will replace it into that u. So I end up with 2/9 times x cubed plus 1 raised to the 3/2 plus c as my final answer. Now, that is technically the end of solving this problem, but you should always check your work. So let's go ahead and do that here. We want to check if the derivative of this is my original thing, right? The original function that I started with in my integral. So I need to apply the power rule. I'm taking the derivative of this answer, 2/9 x cubed plus 1 to the 3/2. So I'll apply the chain rule. So I have 3/2 times 2/9 times x cubed plus 1 raised to the 1/2. I need to use the chain rule here. So times 3x squared, and then the plus c goes to 0. And then I'll clean it up a little bit. So the 2 divided by 2 is 1. And then I end up with 3 and 3. So I end up with 9/9 x squared times x cubed plus 1 to the 1/2. 9/9 also equals 1. And this is what I started with. If I go back up here, to my original problem, I started with x squared plus the square root of x cubed plus 1. And that is good. So it's always nice to know that you did, in fact, take your derivative or take your integral correctly. Thank you so much for watching.